Okay, so this is assignment 4 for SLHS 1302. For part 1, we have 3 concepts that we want you to define. These concepts are probability, probability distribution, and expected value. And so you can find these concepts and their definitions in the Unit 2 lectures under Chapter 4, Probability Theory. So if we go into these notes, we'll see on the second page, we have the definitions for probability and expected value. Probability means the percentage or proportional chance of a particular outcome. Expected value means the outcome that is expected to occur based on a particular model. And then lastly, probability distribution is on the fourth page, and it means a family of distributions used to plot the probabilities of all possible outcomes of a trial or a set of trials. And so this could be a table or bar plot showing the distribution of all the possible outcomes and their relative frequencies. So if we go back here, you'll just want to fill in your own words the definitions for these concepts. And then for question 2, it says, using the terms in number 1, fill in the blanks in the following paragraph. So that means these 3 terms will be used to fill in these 2 blank spots here. So you'll only be using 2 of the 3 terms. So the question that you have is, there are 10 blue balls, 6 red balls, and 4 yellow balls in a black bag. Assuming you cannot see the inside when you draw a ball from the bag, so you cannot pick which ball you are drawing out. Each time you take out a ball, you will put it back in the bag before the next drawing. So for part A, it says, for each drawing, the blank of getting a blue ball is calculated as 10 over 10 plus 6 plus 4, which equals 1 over 2. And so you would then want to pick the most appropriate concept from up here. So if we can recall, if we go back to the notes, we see that probability distribution is a family of distributions, whereas probability is the percentage or proportional chance of a particular outcome. So if we go here, we see that it's showing us that chance of getting a particular outcome, which would be drawing a blue ball from the black bag. So then we know that the term that goes here is probability. All right, and then for part B, it's asking if you repeat the drawing for 10 times, the blank for blue, red, and yellow balls are 5, 3, and 2. So we already know it's not probability. If we go back to the notes, we can see that expected value is the outcome that is expected to occur based on a particular model, whereas probability distribution, once again, is that family of distributions used to plot the probabilities of all possible outcomes. So we then know that the term that fits here is expected value, or expected values, because these are the values you would expect to get based on this model when we are drawing 10 times. So if we want to do the math for this, just to understand why it is we're getting these values, we can use this probability for the blue ball as an example. So if we were to draw from the bag, what would our probability for getting a blue ball be? So it'd be 10, because there are 10 blue ones in the bag, and then it would be out of all of the balls that are in the bag. So we know that there's 10 blue, 6 red, and 4 yellow. And so we then get 10 over 20. So we have a chance of, there are 10 balls out of the 20, or 10 blue ones out of the 20. So this would equal a probability of 1 over 2. All right, for the red balls, we know that we have 6. We know that there are 20 in total, so the probability of drawing a red ball would be 6 over 20, which is equivalent to 3 over 10. And then lastly, for yellow, we have 4 yellow balls out of the 20, so the probability would be 4 over 20, or 1 over 5. All right, and so now if you wanted to calculate the expected values when you do a repeated drawing 10 times, you would then take the probability, times it, or multiply it by that 10 times that you would be doing that. So 1 over 2 times 10 gives us an expected value of 5. So out of those 10 times that we're drawing balls from the bag, we would expect 5 of them to be blue. For the red, we would multiply it by the 10, so the 3 over 10 by 10, which gives us that value of 3. So for the 10 times we were drawing, we would expect 3 of the balls drawn to be yellow or red. And then lastly, for yellow, we would do 1 over 5 times 10 to give us a value of 2. So with that repeated drawing of 10 balls, we would expect 2 of them to be yellow. And so this isn't something you need to do right now. It just is to help explain what these values mean to you. All right, now so for part 2, we are going to do some exercises on probability. So it says please answer each question and enter your answers in the yellow region. Each question is worth half of a point. So for question 1, it says what is the sum of the area represented by a probability distribution? So if we look at this right here, we see that we have values 1 through 6 listed, and on the y-axis we have 1 over 6. So each of these bars represents 1/6. So if we were to sum the area, we would do 1 over 6 plus 1 over 6 plus 1 over 6. So what we're doing is just adding 1 over 6 or 1/6 together 6 times. So 1, 2, 3, 4, 5, 6. And then we'll see that this equals out to be 6 over 6, which equals 1. So the sum of the area represented by the probability distribution is 1 because we have 6 different bars, each equaling out to 1/6 on their own. So combined, that would be 6/6, which equals 1. All right, so for number 2, it says calculate the probability of getting a 1 or a 2 on one roll of a die. So keep in mind that or means that you're going to be adding the probabilities together. So the probability of getting a 1 when you roll a die is 1 over 6. And the probability of getting a 2 is also 1 over 6. So we're going to want to add these probabilities together. So it'd be 1 over 6 plus 1 over 6 equals 2/6, which also equals 1/3. All right. And so for question 3, it says calculate the probability of getting a 1 on the first roll and a 2 on the second roll of a die. So it says hint and means multiplication. So what we're going to want to do is multiply the first probability by the second. So as we said before, the probability of getting a 1 is 1/6, and the probability of getting a 2 is also 1/6. So we're going to want to multiply the 1/6 for getting a 1 and the 1/6 for getting a 2. And so our answer would then be 1 over 36 because we're multiplying the 1's by each other and the 6's by each other. So 1 times 1 equals 1, 6 times 6, 36. All right, and then for question 4, it says, suppose you visit a village that has 120 males, so 70 are boys and 50 are men, and then the village also has 140 females with 80 girls and 60 women. It's asking, what is the probability for you to run into 3 girls in a row? And then suppose after you run into each girl, that girl walks with you. So let's split this up into 3 events. So you have event 1, event 2, and event 3. So what is the probability of running into a girl on your first chance? So the probability of event 1 would be 80 because we have 80 girls over the 120 males plus 140 females. So the reason we're doing that is because there are 80 girls, and then you have a chance of running into anyone in the village, which would be 120 males and 140 females, and we want to know the probability of running into a girl out of all of those people. So our probability would then equal out to be about 30.7%. All right. And so for event 2, we want to now know what the chance is of running into another girl, assuming that the last girl we ran into is now walking with us. So we would do 80 minus 1 because there is now a girl walking with us out of the 120 males plus 140 females minus the one who is now walking with us. So if we wanted to simplify this, it would then equal out to be 79 over 120 plus 140 minus 1. So that would be 260 minus 1, so 259. And so this will then give us a probability of 30.5%. And then if we go back to event 1, just to simplify that one for us, it'd be 80 over 260 to get us that 30.7%. Okay, and so now event 3, we want to know what the chances are of running into a third girl, assuming that the last 2 girls have continued walking with us. So what we will do is 80 minus 2, because they're the 80 girls minus the 2 who are walking with us, and then the same with the 120 males plus the 140 females minus the 2 girls that are now walking with us. So simplified, this would be 78 over 258 to give us a probability of 30.2%. And so now we got to consider that we are looking at an and event. So we're looking at running into a girl on our first time, our second, and our third. So what we want to do now is we want to multiply these different events by each other. So what we would do, if we remember up here, the AND operation means multiplication. So we would want to multiply 30.7% by 30.5% by 30.2%. So to do that easily, we would want to convert these percentages into whole numbers. So we would have 0.307 times 0.305 times 0.302, and our value that we get is 0.028, which equals 2.8%. So that means the probability of these 3 events occurring would be 2.8%. So the probability of running into 3 girls in a row would be 2.8%. And keep in mind, you can be using R to calculate these values for you. So say we wanted to calculate event 1, just for an example right now, what you would do is go into R, open up a new script, and then type in the equation that you have. And then run that. And so you'll see the value down here. So we get 0.307. If you wanted to convert that into a percentage, it would just be 30.7%. And so you could do that with all of these events, or even with these questions up here, as well as if you wanted to try and calculate these values up here. So you can use R as a calculator. Okay, so now for part 3, we're going to use R to recreate this graph shown right here. So what this graph shows is a group of patients in a hospital. So these patients are split into different categories of aphasia. So 30 patients have Broca's aphasia, 8 have conduction aphasia, and 16 have Wernicke's aphasia. So what we are going to do is recreate this graph by using these values right here. So first, like always, what we'll want to do is create our directory. So this first set of code lines is for Windows users, second set are for Mac. Remember to replace the X's with your username. And if you're still having trouble finding your username, go back to assignment 3 under the creating a directory section, and you should be able to get that code line, which will find your username for you. and that's in assignment 3. All right, so what we'll do is copy the code lines that match our laptop. So you'll paste them into R, replace the X's with your username, and then run those lines. And then I'm getting an error because I've already created this folder before. And then if we wanted to make sure that we're in this working directory currently, we would run get working directory, run that line, and then it shows us the directory we're in. So it shows us the assignment 4. All right, so now that you've created the directory, you can move on to step 1, which includes inputting the data. So right here with this code line, we're going to be creating a variable called data, and it's going to have the numbers from up here. So what we want to do is replace this highlighted section with our values. So if we recall, our values for Broca's aphasia is 30, our value for conduction aphasia is 8, and our value for Wernicke's aphasia is 16. So then you'll copy this code line and run it in R and run that. And so we'll see over here in the global environment, we've created this variable called data. All right. And so now what we're going to do is assign the names of each of these categories to these values. So our first name, which goes with the value of 30, is Broca's. So we type in Broca's. The name that matches or goes with the value 8 is conduction. And then the name that goes with the value of 16 is Wernicke's. All right, and you can, as I said before, find this information up here. So we have the 30 for Broca's, 8 for conduction, and 16 for Wernicke's. All right, so then you'll copy this code line, paste it into R, and then run it. And so now these names have just been assigned to those values. Okay, so now we are going to plot these results. So we are going to use the bar plot function to create a bar plot. It says inside the parentheses, we first put the name of the variable to be graphed. So we know the name of this variable, as we see up here, that when we were creating the variable, its name is data. So we'll replace this highlighted region with the name data. And then it says then we will also assign a title to the x-axis and the y-axis using the arguments xlab, ylab. So we see that there's a spot for us to fill in the name for the x-axis. And so we'll put in category of aphasia. And so we can also find that if we go back up to our graph that we're trying to recreate, on the x-axis, the title they have is category of aphasia. And then for the ylab, it already gives you the title that you're going to want to use, which is number of patients. So then we'll copy this code line and run it in R. So copy, paste, run. And so we're seeing our graph pop up over here. And then if we go back to the Word document, it also is showing us a code line for giving our graph a title. So we'll copy that code line, go into R, paste it, run it. And so then we'll see the name pop up over in the plot section. So if you go back to your Word document, it's showing that you're going to want to save this image and then also insert it into your assignment document. So we'll copy these lines for saving it. And we'll run them. And so you'll see down here that they ran to be saved. And so then you can export the image however way you prefer to save it in your document. And so I just usually save it to my desktop so I can access it later. Right. So if you see it's over here on the desktop, we'll just drag it into the assignment. And so this is the image you should have created through those code lines. All right, so now for step 4, we are going to convert this data into percentages, and then we are going to plot them. So if we remember, the name of this data set is called data. So what we will do here is get rid of this highlighted section and replace it with the formula for converting the numbers into percentages. So if we recall, this formula is data divided by the sum of data multiplied by 100. So what this is doing is it's just taking each individual value and then dividing it by the sum of all of those values and then multiplying it by 100 to convert this number into a percentage. So it is something kind of like what we were doing up here with question 4, where we were converting these basically values into percentages. All right, so you'll want the code line to be percent equals data over sum of data times 100. And so we'll copy that and paste it into R, and then we'll run it. And then we'll see here that the percentage variable has been created. And so what that is it's just representing the percent name is representing our percentages for the data variable. All right, and so then if we go back to the Word document, we're going to see for step 5, we want to generate a pie chart. So it's saying we're going to use the function pi to graph this pie chart. Inside the parentheses, the first thing we're going to want to do is put the variable that we're graphing. So we're wanting to graph the percentages of the data variable. So we are going to type in percent. And so this is what we will be graphing. It says if you would like to also use specific colors, you can include the argument color after the comma following our variable name. So what we can do is do percent color equals C. So we'll have red for Broca's, blue for conduction, and yellow for Wernicke's. And so then you can copy this code line and paste it into R, and then run that, and we will get the pie chart over here. So we see, as I said, that we're having the red color for Broca's, blue for conduction, and yellow for Wernicke's. All right, so if you go back to the Word document, it's going to want you to save the image and then also insert the image into your document. So you want to take these code lines and then copy them into R, paste, and then run. All right, and then we'll export the image. And then drag it into our assignment. So the image you should have looks like this. All right, and then lastly, we're just going to want to save our history. So we'll just copy this final code line into R, run that, and that'll save our history into our folder for SLHS1302 Assignment 4. All right, and so just to go through what you need to have filled out in this assignment, so we'll go at the beginning. So you want to have your 3 definitions for the concepts probability, probability distribution, and expected value. You'll want to have these 2 spaces filled in. So for part A, you got probability, part B, it was expected values. And then for part 2, you will have an answer to 4 questions. So for question 1, we remember that we were adding up the area for this probability distribution, and it ended up equaling 1. For question 2, we were trying to see how 2 probabilities add up together to equal an expected outcome. For 3, it was multiplying to get a probability. And then for 4, it was looking at a number of events all together and what the probability of those events occurring together would be. And so for 1, the answer is 1. 2, it is 1 over 3. For 3, it is 1 over 36. And for 4, it is 2.8%. All right, so for part 3, we were creating this graph. So we had to put in the values for the 3 different types of aphasia. We then had to fill in the names that go with those values, so Broca's, conduction, Wernicke's. And so you'll want to remember to have these filled in your assignment document that you upload onto Canvas. And then we had to fill out this code line for the bar plot. So we were looking at the variable data. We wanted to give the x-axis the label category of aphasia. And then we inserted our bar plot. All right. And then step 4, we were converting the data into percentages. So we had to fill in this formula here. We then wanted to create a pie chart of the percentages, and then we also assigned colors to those different names or categories of aphasia. And then lastly, we wanted our pie chart. So in total, this is 10 points. So 4 for part 1. So 1, 2, 3, 4. A half point for these questions, so that's another 2 points. So we're at 6 points at this part. And then a half point for these filled in areas. A half point for the graph. Half point for each of these filled in areas. And then a half point for the pie chart. And that is it.